The JPEG has been, by a metric mile, the web's most favored format. Its lossy properties made it ideal in dealing with some of the web's emerging constraints. But in nearly 30 years, so much has improved, from codecs to computing power. So in comes the mighty JPEG XL, the format meant to address some of the JPEG's past shortcomings while still providing a powerful feature set for modern browsing on modern devices. So it would be absolutely unthinkable to have a conversation around this format without enlisting the following engineer. So here to deep dive into the details of the JPEG XL is Jan Snares of Cloudinary. Enjoy.
Okay, hi everybody. This has been so far a very interesting event, and I'm sure that speakers after me will also be very interesting. I hope I will also be somewhat interesting. So I'm going to talk about JPEG XL, and JPEG XL, I like to think about it as the next generation alien technology from the future. So this quote comes from Tim Terryberry, who called the original JPEG some kind of alien artifact, some kind of alien technology from the future. And I think this is an interesting statement because in a sense, I think it is true that JPEG, as we know it, hits a kind of sweet spot in terms of a combination of elegance and simplicity and power. It has been around for like 30 years now, and the fact that it's still around indicates that it's actually it was very good for its time. But what we want to do in JPEG XL is basically make the next generation of this type of alien technology from the future, and hopefully something that will also last for like 30 years. Which is, of course, an ambitious goal, but well, we can try. So this talk will be about what is JPEG XL, what is this next generation JPEG. So JPEG is both the format and the committee. So it's a committee that works under ISO IEC, and also works together with ITU to produce standards. It's the committee that produced the original JPEG. It's the committee that produced JPEG 2000, which Pierre will talk about. And it's the committee that's making JPEG XL as well. So JPEG XL has been mostly a collaborative effort of a Google team and a Cloudinary team that have basically created this codec. So lots of people were involved. In particular, I'd like to mention Jirki, Luca, and Jan, who really did a lot, but the others also did quite a lot. So this Google team, it's the Google compression team from Zurich. They have done quite a lot of interesting things for web developers. They are the people who made Broadly, the general purpose compression, the WOF font format, Lossless WebP is also one of their things, the Zopfli PNG recompression, the Gretzley JPEG encoder, the Brunsley JPEG recompressor, and also the PIC image format, which is what went into JPEG XL. As for the Cloudinary side, I made the free lossless image format, FLIF, and later extended it into FWIF, which was the free universal image format. And a lot of this also went into JPEG XL. So JPEG XL started out basically as a combination of PIC from the Google team and FWIF from myself. So these were two proposals originally 2 years ago that were submitted in response to a call for proposals from JPEG. And about 2 years ago, it was decided to take these two proposals as a starting point. And since then, we've basically been combining the IDs from these two codecs to build a single coherent integrated codec And what we ended up with is actually, it's better than just the sum of the parts. It's better than just what we started out with. I will talk about it. So the next steps now in this standardization process are to finalize the specification. So next week actually is a JPEG meeting. Hopefully the part 1 of the JPEG XL spec will proceed at that JPEG meeting to the FDIS stage, the final draft international standard stage, which means that the core code stream is nearing completion. Hopefully we will soon have an international standard. So let's dig in a bit. What can this codec actually do? Why should you be interested in it? So first of all, we preserved things from JPEG. If it's good, there's not really a reason to change it. And there are good things in the original JPEG. So the DCT, the discrete cosine transform, is still a very good method of doing lossy compression. And there have been attempts to try other things, but DCT still seems to be a very good thing to have in any codec. Also, JPEG can do progressive decoding, which is something we want to keep. And it made the decision to make chroma subsampling an optional thing. So you can do 444 or 420 or some other subsampling modes. And we wanted to preserve this flexibility. And basically by preserving these things, the DCT and so on, we have been able to create a JPEG XL format that is, in a sense, a superset of JPEG, which means that an existing JPEG file can be directly translated into a JPEG XL file, where you still get some size savings of about 20% just by using better entropy coding. But it's basically exactly the same data. So you're not decoding the JPEG to pixels and then re-encoding it in a new format. You're just directly translating the DCT coefficients from the JPEG into a JPEG XL. And the advantage of that is that it's a lossless and reversible operation. So you don't have to worry about generation loss or introducing extra artifacts. Also, you don't have to worry about creating a new file that is actually larger than the original, which can actually happen if you have a low quality JPEG and then you decode it to pixels and then re-encode it with a new format. The new format might have to spend quite some effort on getting the JPEG artifacts right, which is a bit of wasted effort. And in the end, you end up with a file that is larger than the original JPEG. So this kind of thing cannot happen. But you can also reverse the process and get back to the original JPEG, which I will talk about a bit more, is a very useful feature to have. We added a lot of stuff on top of that. So instead of just having the 8x8 blocks that you have in the original JPEG, we have what we call variable DCT. So you can have blocks that are as small as 2x2 up to 64x64. You can have rectangular blocks as well. So there's a lot more types of block sizes. Also, these blocks can be floating blocks. They can appear anywhere, so they don't have to be naturally aligned. So you can basically use bigger blocks in areas where everything is a bit smoother, and use smaller blocks where you need more detail. We also made some effort to make the progressive aspect of it better and actually more usable. I will talk a bit more about that later. We use a different color space, the XYB color space, which is perceptually more relevant than the old YCBCR. We have the option of adaptive quantization, which means that you can basically tune or scale the amount of quantization per block instead of just globally, which means you can really fine tune the artifacts you get. We have some new coding tools that are quite cool, patches, splines, and noise. If there's time, I will gladly explain them. We have 2 filters, restoration filters that for deblocking, basically. We have a lot better entropy coding. That's basically the main thing that is lacking from the old JPEG. We support lossless, we support high bit depths, even up to 32 bits per channel. So that's more than anyone would need, I guess. We do support alpha depth, thermal maps, whatever extra channels besides the image itself. And it's supported directly in the JPEG XL code stream, so you can also do it progressively and so on. We do support animation, multi-frame. We do support layers. The animation part of it, I want to clarify. It's still an image codec, a still image codec, and you can use it for animation, and it might make sense if you want to do lossless animation. But for most types of animation, I think we should really move to video codecs. It doesn't really make sense to use still image codecs that don't have any real interframe features. To use those for animations, even for short GIF-like animations. Of course, we can easily beat GIF in terms of compression, but a video codec will still be better. So I think the web should move to video for actual video material. But the format does support animation and multiple frames. And also it supports crop T code, so you can have huge images if you want, a gigapixel or even larger, and efficiently decode just one region of interest in it without needing to decode the whole image. And this is a feature that was also missing from the original JPEG. Okay, so this is what the original JPEG block diagram looks like. It's relatively straightforward. You do color conversion to a YCBCR, chroma subsampling optionally, and the DCT 8x8, and then either sequentially send out all the blocks or progressively send the information in multiple passes, and then have a simple prediction, simple entropy coding, and that's your code stream. In JPEG XL, things have become a bit more complicated. We have 2 different modes and they use one another. So we have a DCT, variable DCT mode, which is the green thing here. And we have, and this one basically derives essentially from the PIC image format. And then we have the red thing, which we call the modular mode, which basically derives from FWIF, although a lot of things have been interchanged in the meantime. And so, for instance, the DC part of the image, so the 1.8 resolution version of the image, it's actually encoded using the lossless codec. So you can have all the fancy prediction and whatnot. And also, there's like lots of ways in which these are intertwined. I don't have time to go into detail about how it works. It's a bit more complicated than the original JPEG, but the point I want to make, it's not that much more complicated. So it's a lot more powerful, but it's not really that much more complicated. So it's also not slower. Both encode and decode are actually fast. If you have more than one CPU available, like most modern hardware will have at least 4 cores, then the decode will actually be faster than JPEG because it can be done in parallel. The encoder, well, of course, encoders, you can always make trade-offs between speed and density, but the faster modes of our encoder, they do give very good results. So it's a codec that is designed for software encode and decode. It doesn't require any special purpose hardware, and I think this is important for still images, that it is possible to do everything in software. I think relying on hardware for still images is probably not a really good idea, especially in browsers, where there's always a risk that malicious bit streams will do nasty things and so on and so on. All right, so what are the key features? It's a royalty-free open source codec, just like WebP and AVIF, unlike HEEC. It's a legacy-friendly codec, and so I want to dive in a bit on what that means. So if you have existing JPEGs, like I said before, you can losslessly transcode them into JPEG XL. So this is a nice feature to have in terms of transitioning from a JPEG only world, or well, currently there's other formats as well, of course, but a mostly JPEG oriented world and into a JPEG XL world. One of the main problems that other formats have to get adoption is that there's this transition, and in this transition you have clients that don't support the new format yet. And what happens is that basically, well, the point of image compression is saving bytes, but in your storage, you're not really going to save any bytes because you need to keep the old JPEG around and also make a newer version of it. So maybe the new format only needs half the bytes of the JPEG, but in your storage, you're going to basically have the JPEG plus the new format. So instead of saving 50% of the bytes, you're actually multiplying your bytes by 1.5. So this is, from a storage perspective, not that useful. What we can do instead is transcode the JPEG into JPEG XL and store only the JPEG XL. And then whenever a JPEG is needed, you can transcode on the fly. It's a very cheap transcoding process. Transcode it back to JPEG and send out the JPEG to the client. But if you have a newer client that does support JPEG XL, you can directly send the JPEG XL bitstream and save bandwidth as well. So this allows you to have a solution that works in the transition. Once you have more clients that update and you're encoding new images from pixels, not re-encoding existing JPEGs, you can also encode your images in a JPEG XL bitstream that is still that is still transcodable to JPEG and will work, but that will look slightly better on a JPEG XL, in the JPEG XL version. So you can get quality improvements as well as size savings. And then when enough clients have updated so that you don't need the JPEGs anymore, you can use the full power of JPEG XL, and this will of course give the best results. Yeah, at that point, you can no longer transcode it back into old JPEG. So in terms of progressive, we have quite some features. It's a file format that was designed to be ready for responsive web design. So we can do the usual progressive decode like in JPEG, but in a better way. And we can actually send the half resolution image just by having a truncated version of the file. So you can use the same file for both the 1x and the 2x version of the image, which helps to save bytes, but is also probably useful in terms of CDN behavior, because you basically have fewer variants. And also, if you want to do things like fetch higher resolution images only when needed, then you could allow browsers to just get the lower resolution version initially, but then when, I don't know, when you rotate the phone so that the image needs to become bigger, it only needs to download the remaining part of the file instead of having to download a new version of the file. We can also do saliency progression. So for instance, you can, in a big picture, send the people that are in the image in more detail first, and then have the details about the background later. This is an interesting feature. We can also do the DC image progressively, so you can really use it for a low quality image placeholder that is built into the format. So basically the first 100 bytes will give you a rough preview, and then it only gets better from there, of course. And we can also reorder the internal tiles. So it doesn't have to be top to bottom. You can start out in the middle of the image and then spiral your way out. So we can start with the middle part of the image. And this is, for instance, also useful for things like 360, where the default viewport is often in the middle. So it makes sense to send that data first in higher resolution. So in a sense, JPEG XL does support middle out compression, if you need the buzzword. Other than that, it's a codec that has been designed with high fidelity in mind. It's mostly, it's very good at the operating point where you have visual transparency. And for still images, I think in many use cases, you can actually afford the bit rates to have visually lossless compression. There's no need to go down into the very low bit rates like 0.1, 0.2 bits per pixel that you would need for video. So I think it's useful for still images to be focused on this area, like roughly around 1 bit per pixel, where you have really good quality, but of course still lossy. And one of the interesting things in the reference implementation for JPEG XL is that we have a fully automatic encoder, and this is something that doesn't really exist for any other format actually. So in traditional JPEG encoders, there is something that makes it a bit hard to automate, which is how do you select what quality to use? Do you, like in libjpeg or mosjpeg, do you use quality 70 or 80 or 60 or 90? Do you want to use chroma subsampling or not? This is something that is really image dependent, and you need to see what happens to know whether it's okay or not. So some images can look perfectly fine in JPEG quality 50, whatever that means, while others can have problematic artifacts even if you bump up the quality to 85. So the problem there is that encoders are configured using technical parameters of the format. Basically, you're saying what scaling to apply to the quantization table, but you're not specifying a visual target. And this is something that we wanted to fix in the JPEG XL encoder. So in our encoder, you specify a visual target in terms of what kind of Bernoulli score do you want to, or Bernoulli p-norm score, I should say, do you want to reach? And then the encoder will automatically adjust the adaptive quantization and so on, and all the parameters to actually reach the visual target instead of just doing something that might give different results for different images. So you only need to select like what kind of visual target you have in mind, and then it will be perceptually uniform across all of your images. Here are some relatively old benchmark results. We have a bit of a problem doing subjective tests due to the COVID situation. So it's a bit hard now to get people together in a lab and in controlled environments look at images to see how good they look. But the point is, JPEG XL is reaching this visual transparency roughly at the same kind of bit rates as AVIF or HEVC or HEEC. So it's competitive with the other state-of-the-art codecs. So it means it's doing significantly better than the old JPEG. It's also doing usually better than JPEG 2000 or WebP. Yeah, you can basically save about 50 to 60% compared to the old JPEG. But unlike some of the other state-of-the-art formats, we do have low complexity. So we have a fast encode and decode. We have a relatively simple spec. We're just editing it at the moment, but currently I think the page count is at 95 pages, which is relatively small, which is relatively simple if you compare it to the video codecs that are between 600 and 700 pages. It's considerably less complicated, and you can tell if you look at the encode and decode speeds. We are basically getting these are numbers for 4 cores, but I think all hardware currently has 4 or 8 cores. We get basically the same encode speed and decode speed as the old JPEG, whereas for any of the newer formats, this is not going to be the case. Especially encode speed is going to be a lot slower, but also decode speed. So this will have an impact on the overall efficiency if you are able to reduce the size, but you're paying again in decode speed. The overall thing that matters for the end users, typically, at least on the web, is the total time it takes to see something. Yeah, for this, you also need fast decode, as well as progressive decode, which also helps to give a result faster. I have a lot more slides, but I don't think I have a lot more time. Henry, how much time do I have left?
Hold on, let me take a quick look at my watch here. Boom, boom. I mean, hold on. I have too many windows here, and I'm looking at the schedule. That would be this window, and it is John. I mean, we could get into a Q&A right now, actually, if you'd like. Yeah, we should, in fact, unless you have a couple more slides you want to sort of detail. But
well, I mean, it's going to be a bit too much. I have more detail on each of the extra coding tools that you have in JPEG XL, but I'm just going to quickly skip through them, and unless there's questions about specific ones, then I can
I mean, there are
have
quite a
these.
few. There are quite a few questions here, actually. So I wouldn't mind sort of jumping in, and they've all sort of come in a bit of a flurry. So let me start to look at some here. Um, doo, 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 doo.